So we've explained the first normal form. In the first normal form, we explained that each column, each cell must only have atomic values. We want to go to the second normal form. And at the end of that first normal form video, I explained that these two columns, the matrix number and the course code, they make up the primary key. So let's type that out. Now, in second normal form, before you can talk about second normal form, that table must first be in first normal form. So this table is already in first normal form. If the table is already in first normal form, then it must obey this rule before we can say that it is in the second normal form. The rule says that every column that is not part of the primary key, every column that is not part of the primary key must depend on the entirety of the primary key. What does that mean? If you pick a column that is not part of the primary key, first name is not part of the primary key. The primary key only has matrix number and course code. So if you pick a column that is not part of the primary key, like first name, it must depend on the entirety of the primary key, not on part of it. That is, not on matrix number alone, not on course code alone, but on both of them together. Let me give an instance. If I know your course code, which is part of the primary key, can I use that to know your first name? That is, if I only know your course code, can I use that to know your first name? If I know that you are often BCH 201, is that sufficient to know your first name? No, because your first name, if you're often BCH 201, your first name might be Taye or your first name might be Kenny, because both of them are often BCH 201. That means that the first name does not depend on the course code, which is fine, right? Also, if I only know your matrix number, can I know your first name? Yes. If I only know your matrix number, I can know your first name. That means that the first name depends on matrix number, and that's a taboo. What the law of second normal form says that before I can know your first name, I must know both your matrix number and your course code. One of them must not be sufficient to know your first name. That is, only one of them must not be sufficient to know your first name. In this case now, if I only know your matrix number, I can know your first name. That means the matrix number alone is sufficient for me to know your first name. This disobeys the second normal form. In same sense also, with your matrix number alone, I can know your last name. With your matrix number alone, I can know your email. So meaning that these three, they depend only on matrix number, which is a taboo in second normal form. Same way also, with your course code alone, I can know your course title. With your course code alone for this research, I can know your department. With this course code alone, I can know the HOD of this department. That means that this part only depends on the course code, which again it's a taboo in second normal form. If I only know one of those columns that comprises the primary key, it must not be sufficient enough to know to know any other column, right? Before I can know any other column, I must have both. So now this table is not in second normal form. So let's take it to second normal form. We're going to split this table into two, or maybe three, depending on. Let's start then. As time goes on, we're going to see what do we need to do again. So to solve this problem, all those columns that depend only on the matrix number will be on a single column. How these columns that depend only on the course code will be on a single table. So first name, last name, email, and matrix number will be on one table. Course code, course title, department, HOD will be on another table. So for that reason, we're going to cut these ones out. We create a new table. Good. So we have this. But remember that the reason we had separate rows here initially, it was because we wanted to enter different courses. But now the course codes and other things that depend on it have been moved to another table. We can call this the courses table. So that means that we do not need this second row again, since it's the same. It's exactly with the same. It's exactly with the first row. It's exactly with the information in the first row. So we don't need the second row again. We can delete it now. So with this now, the matrix number is sufficient to be the primary key now, because we no longer have duplicate values there. If it were to be like this cannot be the primary key because we have duplicate values. But now, since that has been removed, we no longer have duplicate values there. So the matrix number now can be the primary key of this. Also, if you observe it, this is the same as this. Like everything here, they are the same. So we can remove this. So with this now, the course code is sufficient to be the primary key. So this is one table, this is the students table, this is the courses table. But a little problem before we proceed. How then do we now know the courses offered by a student? We should still be able to know. Right? How do we know that? We can then create a new table. This we have matrix number. And the course codes. So 1, if Taye offers, let's say biochemistry, that will be the course code will be BCH201. Then if Taye offers if Taye offers carbohydrates, that will be BCH201. If Taye offers protein, that will be BCH203. If Kenny only offers BCH201, that will be the matrix number, which is 2, that is the matrix number of Kenny, and the course code BCH201. So we have this now. Let's put this. You can call this the enrollment table. So this contains the matrix number and the course code. So we can always come to this table and check which student offers which. Of course, no two rows we have the same values in both columns. Right? No two rows we have the same values in both columns. So now, these tables, all our tables now, they are in second normal form. So there is no partial dependency. We do not have a column that is not part of the primary key that depends only on part of the primary key.